So here's number 7 from Summer Review 7, and this is y equals x squared plus x minus 6. And I factored the top, if anything, just to help me with my zeros, because anything that makes the top 0, not the bottom, will be a 0, or when y is, we'll make y 0. Let's start what happens when x is 0. When x is 0, what do we get? Well, 0, 0, that's going to be negative 6 over negative 3, which is just 2. So we know we have the point 0, 2. I had to change my scale on these because to go by 2s, because it's necessary by the way the graphs look. And then y is 0 whenever the top is 0, so when we have 2 or negative 3, y will be 0. When x is 2 or negative 3, or I could say negative 3 or 2. So when x is negative 3, that would be right over here. Or when x is 2, that would be right over there. So those are the points that are on the curve. Now we look at this where you don't have any horizontal asymptotes because the degree of the top is 2 and the degree of the bottom is 1. So no horizontal asymptotes. But we do have a vertical asymptote at x equals 3. And now because the degree of the top is exactly 1 more than the degree of the bottom, the degree of the bottom is 1, the degree of the top is 2, we do have what we call a slant or oblique asymptote. We can find that out by dividing the denominator into the numerator, and I just did that over here to save a little bit of time. So here's my long division. I divide x minus 3 into x squared plus x minus 6. I end up with x plus 4 plus this remainder. So we just omit the remainder, and y equals x plus 4 is the slant asymptote. So you take a look at that long division. Okay. So this is the slant asymptote. So the slant asymptote, or oblique asymptote sometimes it's called, is the line y equals, and it's going to be x plus 4. So let's draw that one first. The intercept is 4. And the slope is up 1 over 1. I'm going by 2's either way, so it's still going to work out like this, or up 2 over 2. Oops, sorry. Because the intercept is 4, so there's my slant asymptote. We draw it accurate here. And there's my vertical asymptote was at x equals 3. Kind of white out this little dot that I made by mistake here. Doesn't belong there. And then x equals 3 is the vertical asymptote, so I'm going to have to kind of divvy this up here because I'm using a scale of 2's. There we go. Now I know these points are on here, so it looks like it's going to go like this. I can pretty much assume that that's going to happen. So since we have those points on there, let's kind of go with that. That's like some checkpoints over there by the asymptote, so we'll say it's going to look like that. I don't know how high up it's going to go, but I gotta get that closer. That's not good. Trying to make sure that they're approaching, not veering away from the asymptotes. It's a problem with using ink. It's easy to see for you guys, but if I make a mistake, it's hard to fix. Alrighty, so we want that to get closer and closer to the red line, not never veer away. Worst case is it stays the same distance, but so there's the bottom branch of that, and I got the same thing going over here. Make sure it's approaching the asymptote. Okay, something like this. All right, and then we have to figure out where we're going to be. We could be over here or over here, and you can always try a checkpoint, but let's use that other technique we were talking about, which is just to check to see where the function is going to be. Is it going to be going down towards negative infinity or positive infinity? As you know, x approaches the asymptote, and we don't need to worry about it as it's approaching -3 from the left, just -3 from, 3 from the left, or negative direction. Just have to worry about how it approaches 3 from the positive direction. So let's say as x approaches 3 from the positive direction. So what are we going to have? So if we look over here at this, we're going to have y equals, so we can substitute 3 in for the top, and that'd be fine. We just have to worry about the bottom, so we're going to have 3 plus 3, and then I can put 3 in here, 3 minus 2, and the bottom I can't put 3 in because I have 0, so I've got x minus 3. And that's going to end up with 3 plus 3 is 6, 3 minus 1 is 1, so 6 times 1 is 6 all over x minus 3. So let's say we're going to be approaching it from the positive direction, so let x be real close to 3, so we would have 6 all over, so x is approaching 3 from the right, so 3.0001, or even more zeros if you want, minus 3, and that's going to be the same thing as 6 over, and this is going to be positive, so it's going to be just 0.0001, and signs are positive, so it looks like it's going to be positive infinity. So it looks like I'm going to go up here. So that pretty much locks in my curve. So I'm going to come down right like this, and something like that. Okay? So that's what that should be what we have. All analytical, no calculator yet. We'll check with a calculator. Touch that up a little bit. So our points helped us, so we didn't have to do too much of this very small approach. I hope you're getting the hang of that. And let's see what we got here. So again, when you draw these, make sure they're approaching the asymptote, not moving away. That's a no-no. So I think that's a little bit better. Okay. So let's graph this. Sorry, I already put it in my calculator to save a little time because I only have about, I guess the maximum on these videos I can make is 12 minutes, and some of these have been taking a little bit longer. So this is what I put in, and in reality we have to realize that I'm going to have to change my window, so my window is going to be like -16, kind of match my graph paper. No, use the wrong negative, sorry. Clear. Remember, we have to use the little negative down here by the answer sign. -16 to 16. For x, scale 1 is fine, and then -16, and to 16 for y. And let's see if we're going to kind of look like this graph here. I can't graph anything. Well, I could graph that asymptote over there. Actually, if I go back over there, I did. That's the x plus 4. So there's my slant asymptote, and here's my graph. So if we graph this thing, here comes the slant asymptote. So, oh, I'm sorry, there's a curve. And there's your slant asymptote. So it looks pretty close to this. And the vertical asymptote is like right over there, the red line here. We can't graph vertical lines on our calculator unless we get into the parametric mode, of course. All right, so it looks like that's pretty good. rendition of what we got. And again, like I didn't have too much room over here to do the work, so I did a long division to find the slant asymptote over on a separate sheet. That's fine either way, okay? So that's number 7.